In this video, I will explain about a class called PriorityQueue. This class represents a data structure called heap. There is one data structure, well-known data structure called heap, and this is implemented using array as a basic data structure. We have observed that every other data structure is either implemented using array or also linked list, right? So this is implemented using array. I will explain a little bit about heap, which is used as priority queue. A priority queue means the elements are inserted or deleted based on the priority. Then how the priority is decided? Depending on the value of an element. If an element is small, then its priority is high. If an element is large, then its priority is low. So this is the criteria followed. So if we have the numbers like 10, 25, 15, 8, 26. So the highest priority element is 8 and the least priority element is this 26. In this data structure, we cannot decide which element we want to delete. Always highest priority element will be deleted. So it is having the method like just you add the element, means insert the element. And when you want to delete, so just say delete or remove an element. We cannot say which element we want to delete because the elements are deleted based on the priority. Always highest priority element is deleted. Let us study a little bit how this is implemented. So this heap is implemented using binary tree data structure. Binary tree. So I have taken a binary tree here to show you how insertion and deletion operations may happen. So I'm not explaining you how actually this class works, but I'm explaining you the concept behind this one, that is heap concept. How these elements are stored inside this binary tree is always the highest priority element, means small element will be in the root. And when you delete, only the root element will be deleted. And once the element is deleted, the next smallest element will appear here. Let us insert few elements and see how it may work. First, I have inserted 20. So 20 is in the root. This is the only element. We don't have any other element. Now next, if I am inserting 10, 10 is filled here, but 10 is smaller than 20. So this goes away and 10 comes here. So 20 will take its place. So the shifting of elements may be done. So this is 10 and this is 20. Now next element is 30, suppose. So 30 is here. Okay, 30 is here. Next element I am inserting is 5. 5 is smaller than this one, so this should move up. And again smaller than this 10, so it should move up. So 5 should go up and sit here in the root. So 5 should come here. And 10 should go in the place of 20. 20 should go in the place of actual 5 comes here. So 20 should go here. So this is the new arrangement of elements. So we have 5, 10 and 30 and 20. So you can see that when I am inserting an element, it is being shifted along the height of a tree. And the height of a tree, if you have the idea about data structure, then the height of a tree is log n. So yes, the time taken for inserting an element in a priority queue is log n. Now suppose the next element I am inserting is 15. So 15 is inserted here. The blank space is here. See, one more important thing is spaces are not left blank. So we cannot have null values in priority queues. So we cannot leave any space null. So when 15 is inserted here, so 15 is smaller than the new value, that is 10 here now. So it remains there only. If I insert 3 next, if I insert 3 here, then 3 here. So 3 is smaller than 30 and 30 is smaller than, actually 5 is here right now. 20 is here. Okay, I have shifted them. So 3 is smaller than 30 as well as smaller than 5. So they should move up. 3 should go here, 30 should come here. Again 3 should move here and 5 should come down here. So the new change will be 3 here, 10 and 5, 20, 15 and 30. So this is how insertion is taking log n time. I will redraw this one. Let us see what happens when I want to delete. Always the root element, that is 3, is deleted because this is of highest priority. Then these elements are adjusted to bring a next smaller element here at this place. I will not show you detailed procedure, directly I will update it. So 5 is the next smallest element, 5 goes there and this place is vacant and 30 goes here. So in the diagram, if you see, after 3 is deleted, it will be 5, 10, 30, 20 and 15. This should be the result. So for deletion also, the elements are shifted along the height of a tree. So the height of a tree is log n. So this is enough about heap data structure. If you want to study in detail about heap data structure, there is a video in YouTube. My video is there. You search for heap, you will find about heap data structure. So that's it. The conclusion is that the heap priority queue data structure uses a heap and it allows always a highest priority element to be deleted, and the elements are arranged based on their priority. And one more very important thing. See, the elements that you are inserting here, there should be some method for comparing them. If they cannot be compared, then you should define a comparator for it. You can define a comparator for it. Okay. If that is not available, then it will not work. It may give a exception, class cast exception. It cannot if comparator is not available. And by providing a comparator, we can change the order also. Here smaller number is having higher priority, we can change it to larger number having higher priority. So you can change the order also by giving a comparator. I will show you a program. I will give the demonstration and insert these elements and show you. Let us look at the demonstration for priority queue. This is a part of java.util package. So I should import java.util. So I will take star for it. Then inside main method, I will create an object of priority queue. I am taking a priority queue of type integers. Now next I will create its object. Let us insert the element. The first element that I inserted was 20, then I inserted 10, then next was 30, then I have inserted 5, then later on 15, then the next element was 3. This is what the list of elements I have inserted. Now I will show you the head element. What is the head element? For displaying the head element, I will use p dot. See, add method is there, add, and contains. You can find out whether an element is there or not. This add element takes log n time, contains takes order of n time because it has to perform search in the entire that is priority queue. Then offer. This method is also used for insert. So instead of add, we can use offer also. Okay. And next is peek. You can find out the head element. Poll, this is for removing the head element. And there is one more method called just element. This will give you the head element. So I will use peek. Let us run and see which element is there on the head of a list. 3. Yes, 3 is there in the head of a list. Let us use a iterator and display all the elements. So instead of using iterator, I will use for each method. And in this, I will give lambda expression, which should display all the elements. System.out.println x. Okay. So for each method, I have given lambda expression for displaying all the elements. Let us check what are the elements. See, first I am printing peak, so head. Then after that, 3, 10, 5, 20, 15, 30. Let us check the order I have shown you. See here, 3, 10, 5, 20, 15, 30. I have shown you this one, like how insertion is done. Afterwards, I have deleted 3. So I got this result, isn't it? So after insertion, this was the result. So it is using similar mechanism that I have shown you. Now let us delete one of the element and check. I will delete one of the elements. So for that, p dot pull. I will use this method for deletion. I'm not displaying the element. We know 3 is the element. Okay. So I will copy this one and paste again to show all the elements once again. And here I will give a message after deletion. This is done after deletion. Okay. So let us see what is the result after deletion. Yeah, 3 is deleted and we got the elements, remaining elements are 5, 10, 30, 20 and 15, and deletion takes log n time. Let us see what was the result we got. 5, 10, 30, 20 and 15. Yes, we got the same result. So it is working in the similar way that I have explained you. If you are interested in learning about this heap in detail, you can watch the video. Already I told you. So this is how priority queue works. So you can use it for implementing heap. And when the smaller value is having higher priority means it is a min heap. And if you want to change the order and make it as max heap so that the larger element having higher priority, then you can define a comparator. So I will write on a class for comparator which implements comparator, and it is generic, so I should give integer because I am using integer. Now inside this I should override method public int compare, and it should take two objects of type integer o1 and integer o2. This is the method I should override. Right, when I am implementing comparator I should override this method. Now inside this I will say if value of first integer is smaller than value of second integer, so for smaller number we should return -1, but we will return 1. And if first object is greater than second object, then I should return 1, but I will return -1. Else I should return 0 when they are equal. So my comparator is different. See, larger value is having higher priority. Alright. So now when I am creating a priority queue, I will give an object of my comparator. So now it will follow this comparator. Okay, COM, I have given just COM. So my comparator have given. Now you will see when I peek the first value, I will get the largest element, that is 30. Yes, largest element is 30, and when I am looking at the element, this is 30, 15, 25, 10, and then last is 3. After deletion, the largest element is deleted, obviously, 30 is deleted. So we are having 20, 15, 5, and 3, 5, and 10. So you can follow similar method. The insertion and deletion is done in a similar method, but the difference is that the root will contain the largest element instead of smaller element. So that's it. This is enough for priority queue, and this is commonly used in algorithms, different algorithms. So if it require in your application or an algorithm, then you can use it. So try this class by yourself. Check for this class once.